Hello everyone, a very warm welcome to all of you. This is Raja Rajyavardhan Singh and I am your Geography faculty for General Studies. In this lecture, we will be discussing about the phenomena El Nino and La Nina. So, we will be discussing all these phenomena in detail, and there are already so many videos on this topic, but I have attempted to explain this topic in a different way. So you have to watch this video completely, and all of your doubts regarding El Nino and La Nina for UPSC, all of those doubts will be cleared. So let's start with our topic La Nina and El Nino. As you can see in this image that in case of El Nino or in case of La Nina, in case of El Nino and in case of La Nina, all of these phenomena are associated with the Central Pacific Ocean. And the region between Australia and South America is affected by El Nino and La Nina. So first, what is the region where this phenomena happens? This phenomena occurs in between Australia and South America in the Central Pacific Ocean, and El Nino also occurs in the same region. So what is El Nino and La Nina? These are related to sea surface temperature. First thing is that these phenomena are related to sea surface temperature. As you can see here, La Nina is, here we have shown the blue color. Blue color is for that the sea surface temperature is below than the normal. And here we have shown this red color. And here it means that in the central part of the Pacific Ocean and in the eastern part of the Central Pacific Ocean, the sea surface temperature is more than normal. The sea surface temperature is more than the average value. So in one case, the sea surface temperature is less than the average, and in the other case, in El Nino, the sea surface temperature is more than the average value. So say, if sea surface temperature is, this is the normal level, in case of El Nino, temperature rises by a certain amount, and in case of La Nina, the temperature decreases by a certain amount. Okay, so below the normal value and above the normal value, this is the main thing in case of El Nino and La Nina. The sea surface temperature rises above the average value and the sea surface temperature decreases below the average value. In order to understand this phenomena in entirety, you must also know about the global wind circulation system. So let me tell you, this is the global wind circulation system. So in case of the global wind circulation system, we have to understand a few things. In the case of the global wind circulation system, here we are having trade winds, and trade winds blow between the tropical belt. From 30 degrees north to 30 degrees south, this entire region is dominated by the trade winds. And these winds are moving from the high pressure region near the 30 degree north and south latitude, and these winds move towards the equator. So for now you can understand this like this, that we are having the low pressure at the 0 degree equator, and we are having two high pressure belt at 30 degrees north and 30 degrees south. And wind always moves from the high pressure region to the low pressure region. So the wind is moving from the high pressure region to the low pressure region. Here also the wind is moving from the high pressure to the low pressure region. But because of the effect of rotation of Earth, we are having the Coriolis force, and in the northern hemisphere, every moving object will be deflected towards its right. So suppose if I am moving in the forward direction, because of the Coriolis effect, I would be deflected towards right. So this is the case happening here. The wind is moving from 30 degrees north to equator, and the wind is deflected towards its right. In the southern hemisphere, the rule is opposite. Every moving object would be deflected towards its left with respect to the direction of motion. So in the southern hemisphere, the winds are moving from the high pressure, which is at 30 degrees south latitude, and the winds are moving towards the equator, and as they are moving, they are getting deflected to the left. So the rule is the moving objects, whether it is wind or any other object, will be deflected towards its right with respect to the direction of motion, and in the southern hemisphere the moving object, they deflect towards left with respect to the direction of motion. So one thing is very clear, that near the equator the winds are moving from east to west. So this is also one very important thing in order to understand El Nino and La Nina, that near the equator the winds are moving from east to west direction. So you have to remember this thing. The first thing that I stressed upon is that El Nino and La Nina, these are related to sea surface temperature. So one thing is sea surface temperature. In case of El Nino, it will be more than the average value, and in case of La Nina, it would be less than the average value. I hope this is clear up till now. Now we are in a position to define that what is El Nino-Southern Oscillation. We are calling it the El Nino-Southern Oscillation. Why we are calling it ENSO, the El Nino-Southern Oscillation? So here there are two words, one is El Nino and one is Southern Oscillation. We have combined it and it becomes the El Nino-Southern Oscillation. El Nino and Southern Oscillation. El Nino and Southern Oscillation. El Nino is related to sea surface temperature and Southern Oscillation is related to the air pressure over the surface. The atmospheric pressure just above the surface, this is related to the Southern Oscillation, and El Nino, it is related to the sea surface temperature. I have already talked about the sea surface temperature. In case of El Nino, it is more than the average, and in case of La Nina, it is less than the average. Now there is one more thing, that why this name El Nino? When this phenomena was discovered, it was witnessed by the fishermen which were living on the western coast of South America. So they witnessed that during the December month, the sea surface temperature starts to rise and there are warm currents, there are rainfall in some of the year. And because this phenomena happened in the month of December, they started calling it El Nino, because it is the time of December and these people follow Christianity. So in December we are having Christmas and they follow Christianity. So they started naming this phenomena as the birth of the child of Jesus. And in Spanish, this El Nino means the birth of Jesus. Now, so ENSO, one thing is related to the sea surface temperature and second thing is Southern Oscillation, which is related to the atmospheric pressure just above the surface. Okay, you have already seen that there is wind movement from east to west in case of the Central Pacific Ocean. So the trade winds are moving in general from east to west. Let's move forward. So El Nino Southern Oscillation, now we are in a position to define it, that ENSO is a recurring climate situation. This is a recurring climate pattern involving changes in the sea surface temperature in the central and eastern part of the tropical Pacific Ocean. I have already discussed it, that this is a phenomena related to the Central Pacific Ocean and the eastern basin of the Pacific Ocean. See this diagram. Here the sea surface temperature is changing. It is oscillating about the average value in the central and eastern part of the Pacific Ocean. It is oscillating about the average value in the central and eastern part of the Pacific Ocean. So this is a phenomena of the central and the eastern basin of the Pacific Ocean. Now the next thing, that on periods ranging from about 3 to 7 years, we see this temperature anomaly. The temperature is rising above the average value. The temperature is falling below the average value. So this kind of thing happens. This is not a periodic kind of oscillation. This is happening every 3 to 7 years. The surface water across the tropical Pacific Ocean, it warms or cools by 1 to 4 degrees Celsius. I have already explained this, that when it is more than the average, it warms by up to 4 degrees Celsius, and during the La Nina years, it cools by 4 degrees Celsius. So this oscillating warming and cooling is referred to as the ENSO cycle. Now, so I told you that we are having three things. One thing is the changing of the sea surface temperature, and second thing is the atmospheric pressure just above the water surface, and the next thing is the trade winds moving from east to west. These are the three things, you have to keep them in mind. So sea surface temperature in case of El Nino would be more than the average. See this red portion, it is showing that the sea surface temperature is up to 4 degrees Celsius more than the average, and La Nina, the sea surface temperature is less than the average value, and this is up to 4 degrees Celsius. Okay, so there is a temperature difference of 8 degrees Celsius between the El Nino year and the La Nina year. At maximum, this is 8 degrees Celsius. Now the next thing, we are talking about the pressure. So the sea surface temperature, we are measuring the sea surface temperature in the Central Pacific Ocean and in the Eastern Pacific Ocean. Now we are measuring the atmospheric pressure just above the surface at two representative locations. One location is in Darwin, Australia, and the other location is in Tahiti. Tahiti is an island in the French Polynesia in the Central Pacific Ocean. So Tahiti Island and the Darwin, we are having atmospheric pressure measuring instruments here. So we basically are having meteorological stations here which are mapping the atmospheric conditions. So here basically we are measuring the atmospheric pressure. There is also one more term which is known as Southern Oscillation Index. Southern Oscillation Index refers to the difference of pressure between these two locations. Take the pressure at Darwin and find the value of the atmospheric pressure at Tahiti, subtract them, find the difference, and that would be referred to as the Southern Oscillation Index. So the sea surface temperature and the atmospheric pressure are linked to one another. What is the linkage? That will become clear as we will proceed with this topic. So finally, El Nino is, the Spanish meaning is the birth of Jesus Christ, the child of Jesus, and below average sea surface temperature across East Central Pacific is La Nina, below the average sea surface temperature, and above average sea surface temperature across East Central Pacific is El Nino. So this is clear to everyone. Now I am going to explain the situation. So we have understood three things, that El Nino will be named when the sea surface temperature is more than the average, and El Nino, La Nina will be named when the sea surface temperature is less than the average and the temperature differs by up to 4 degrees Celsius. Now, so the next thing is, I also told you that in the Central Pacific Ocean, near the equator, the trade winds are blowing. The trade winds are blowing near the equator. So trade winds are moving from, this is the eastern part and this is the western part of the Central Pacific Ocean. So this coast is the Peruvian coast. Which country lies here? This is Peru. And this is the Australian coast, Indonesia and Eastern Australia. So normally the trade winds are moving in such a direction. The trade winds are moving like this. Near the equator, these are moving from east to west. And as the trade winds are moving over the water surface, they are pushing the water. So on the surface, we are having warm water because it is heated by the sun. So this warm water is pushed towards the Australian side in the western part of the Pacific Ocean basin. So the warm water are pushed by the trade winds in the western part near the coast of Australia and Indonesia. The trade winds are moving near the equator from east to west. These trade winds are pushing warm surface water towards the coast of Australia, and we can see that the warm water is piling up here, and on this side as the water is pushed away, so in order to take the space of this moving water, some cold water will rise from below and there will be upwelling on the Peruvian coast. And as the warm water is piling up here, because of the warmer surface, the air is rising there. And you have to also remember that there is one more concept, that clouds will always form in regions where the air is rising. Always remember that the clouds are always formed by rising air. So in all those locations where the warm and moist air is rising, we can have the cloud formation. This is a rule. And all of you know that why the warm air rises. If you will take a hot air balloon or a helium balloon, it rises in the atmosphere. Why it rises? Because helium is less dense than the surrounding air. In the same way, warm air is less than the surrounding air and it rises upward just like a hot air balloon. So the clouds are formed by the rising air, and the air must have some moisture in order that the clouds can form. Okay, so this location is warm. The warm water is piling up on the coast of Australia. The water is piling up here. There is warm surface, and above it a low pressure will develop. Wherever we are having the warm surface, the low pressure develops, and relatively in this part we are having the high pressure. You can also think of it like this: the winds are moving from high to low. So here the surface is warm, and over the warm surface always the low pressure forms, because over the warm surface the air starts to rise. And so it is the pressure of the air which we call as the atmospheric pressure. So if the air above you is rising, the pressure will decrease. So the rising air always forms the low pressure. The air is rising here, the clouds will form and there will be rainfall. This is the normal situation. So under the normal circumstances, we are having moderate rainfall in the Indonesia and Australia, and we are having dry conditions on the Peruvian coast, and there is upwelling of cold water. The cold water is coming up to take place of the water which is moving away. So here we are having upwelling and the dry conditions. Here we are having the warm condition, moist conditions, and there is rainfall here. Let us move ahead. So under the normal situations, we are having high pressure near the coast of South America, low pressure near the coast of Australia, and under the normal condition there is rainfall on the Australian coast and dry conditions on the South American coast. In case of La Nina, we are saying that the sea surface temperature falls below. So sea surface temperature is less than the average value, and the sea surface temperature is less by up to 4 degrees Celsius. So in this case, so here the sea surface temperature, in case of La Nina, the sea surface temperature is less than the normal. So we are having cold conditions here. The sea surface temperature is less than the average. We are having the cold conditions in the Central Pacific Ocean and in the Eastern Pacific Ocean. Now, because of the cold conditions, the high pressure situation over the South America, it intensifies. Because the sea surface temperature is low now, and under the cold condition, the high pressure intensifies. And here, the pressure difference between high and low will intensify. So now there is more pressure difference between the South American coast and the Australian coast. In this case, the trade winds will become stronger. Trade winds are stronger now in the case of La Nina. We can also say that in the case of La Nina, the trade winds got stronger and more warm water is piled up on the Australian coast. Many explanations are also given like this. But in reality, this phenomena is not very well understood in meteorology. Actually, the sea surface temperature is related to the atmospheric conditions, and the sea surface temperature will affect the atmospheric pressure just above the surface, and the atmospheric pressure will also affect the sea surface temperature, and together these will impact the trade winds. So everything is happening in unison. Okay, this is not an isolated event. The trade winds are supplementing the warmer conditions here and colder conditions here, and in other words, the sea surface temperature is supplementing the pressure condition, and the pressure is also impacting the sea surface temperature. So these three things are interlinked with one another. So when the sea surface temperature decreases, the surface here is cold and the high pressure intensifies. There is more pressure difference between the South American coast and the Australian coast, and the trade winds will become stronger. Now these trade winds are moving more strongly. There is intense low pressure here and the air rises over the low pressure surface areas. So here the clouds will form and there would be heavy rainfall. On the Australian coast, we will say that there is heavy rain. And on the South American coast, the air is sinking here. The air is rising here. It will complete its Walker cell. So it will start moving towards the South American coast, and as the air will come up till this point, it will become cold and heavy. It will start to sink at the South American coast, and there would be high pressure situation here. There would be high pressure situation here. So we can say that wherever we are having warm surface, there would be low pressure just above the surface. And wherever we are having cold surface, there would be high pressure just above the cold surface. This thing happens in case of poles. So at the poles, the temperature is very low, the surface is very cold, so the pressure is high. So over the South American coast, we are having the colder sea surface, the pressure is high, and the winds move from high to low. At low pressure, the winds are rising, leading to formation of clouds, and then again these are moving in the upper part of atmosphere towards the South American coast, completing the circulation. So such kind of circulation is known as the Walker cell. Moving ahead. In case of La Nina, we can say that the normal conditions are supplemented. Under the normal condition, the winds were moving from South American coast towards Australia, and there was rain at the coast of Australia and near the Indonesia, and there were dry conditions in the South America. This was the normal case. In case of La Nina, the sea surface temperature is less than the average, and these normal conditions are supplemented. The trade winds become more strong in case of La Nina, leading to more rainfall at the coast of Australia and Indonesia, and leading to more dry conditions near the Peruvian coast. Moving ahead. So this is the normal situation. We can see it again. We are having the normal situation. The winds normally are moving from the South American coast towards the Australian coast, and near the Australian coast, because there is piled up warm water here, and wherever we are having the warm surface, the air above the warm surface becomes warmer. It becomes lighter because upon heating up, it expands, it becomes lighter, and it starts to rise. So as the air is rising over the warmer sea surface, so here the low pressure develops because the air is rising. In the upper part of the atmosphere, the air will start moving towards the low pressure situation in the upper part of the atmosphere. And here, as this air will become cool down, this will cool down, it will start to sink near the South American coast, completing the circulation. So this is the normal phase, and in case of La Nina, this normal phase is intensified. The high pressure situation is intensified here, and the low pressure situation is intensified here. The trade winds will blow more strongly. They will push more warmer waters towards the Australian coast, and here there would be flooding, more rainfall, and here there would be intense dry conditions. So when the water is pushed away from this part, in order to take place of the moving water, the colder water from the ocean bottom will rise up, taking the place of this moving water. So here the cold water will come to the surface, and that is known as upwelling. Now the next thing, this is the normal condition. Once again, the wind is moving, the trade winds are moving from the South American coast, Peruvian coast to the Australian coast, and there is rainfall on the Australian coast. Now, so what is going to happen in the case of El Nino? Listen to me very carefully. El Nino is related to the sea surface temperature. The sea surface temperature in the central part of the Pacific Ocean it is going to rise. If the sea surface temperature is rising here, we know that over the warmer surface, low pressure develops. So previously, under the normal circumstances, we have the high pressure situation here near the South American coast. But in the case of El Nino, the sea surface temperature has increased in the eastern part of the basin. So here the high pressure condition, the high pressure situation converts to the low pressure situation, or the high pressure situation is weakened by the development of low pressure situation. And why the low pressure is developing here? Because the sea surface temperature is rising. So in case of El Nino, the normal situations are changed. If the El Nino conditions are very intense, we can have low pressure developed in this part with respect to the pressure here. So this entire wind circulation can be reversed in the case of El Nino. So in case of El Nino, in the central part, the low pressure may develop. So there may be low pressure with respect to the South American coast as well as the Australia and Indonesian coast. So the winds will move in the opposite direction from high to low. And wherever the low pressure is, the air is rising at the low pressure, the cloud formation will be there at this low pressure area. So in the case of El Nino, this low pressure shifts towards the Central Pacific Ocean, and when the El Nino is intense, it may be shifted to the South American coast, leading to the formation of low pressure here. So where the low pressure is, this entire cell changes and the rainfall will occur at the low pressure situation. This high pressure situation would be weakened because of the warmer sea surface. So that is known as El Nino. Why the sea surface temperature is changing? Why it is happening in the period of 3 to 7 years? So this is not very well understood in meteorology. You have to appreciate this fact that this phenomena was discovered in the 90s, and we are knowing more about it only after the 2000, and in the last 1 decade we are getting more and more information about it. Actually, we do not have very crisp explanation for all these events, but what we are having a lot of data about these phenomena, and that data points that every 3 to 7 years the sea surface temperature is oscillating. Sometimes it is getting more than above the average, and sometimes it is getting cooler by 4 degrees Celsius below the average. And the atmospheric pressure over the surface is linked to the sea surface temperature. This is also linked to the trade winds. So we are having 3 phenomena involved here. One is the weakening and strengthening of the trade winds. The second is the sea surface temperature anomaly. And the third thing is the atmospheric pressure over the surface. So all of these are linked with one another. We cannot say that any one of them is primary. Now, so you can see that under the El Nino condition, the rainfall area is shifting towards the Central Pacific Ocean and towards the Eastern Pacific Ocean. Under the La Nina condition, there is heavy rainfall over Australia. But in case of now the sea surface is warm, this pattern shifts towards the Central and the Eastern Pacific Ocean. So I hope that now everything is very clear to you. As the sea surface gets warmer in this animation, when the sea surface temperature increases, the rainfall pattern shifts here. Because over the warmer sea surface, we would be having the low pressure conditions. So now the warmer sea surface is here. But in case of El Nino, we can see that the warmer part is towards the Central and Eastern Pacific Ocean, changing the air circulation above it. So all these phenomena are linked to one another. The motion of the trade winds, the weakening of the trade winds, and the strengthening of the trade winds. The sea surface temperature and the atmospheric pressure condition just above the surface is also linked to the sea surface temperature. Which of them is primary, we cannot say as of now. But what is happening, I have explained to you. This is a very recent phenomena. We are getting information and data about it just after the 2000. It was discovered in the 1990s. Now, so what are the impacts of the ENSO, El Nino-Southern Oscillation, over the weather patterns worldwide? All of you know that we are Indians, and we know that in the case of El Nino year, the monsoon is generally deficient. So we say that the warming phase, that is the El Nino, the warming phase of ENSO. ENSO is having three phases. We have learnt about it. The warming phase, which is known as El Nino, the cooler phase, which is known as La Nina, and the normal phase, which is not having any name. So in the warming phase, in the El Nino year, the monsoon is deficient in India. That is why we are saying that the El Nino is negatively correlated with the Indian monsoon. And the upwelling weakens along the western coast of South America. This thing we have also seen, because normally from the South American coast, the water is pushed by the trade winds. So as the water from here is pushed by the trade winds, in order to take place of the moving water, the cold water will rise up to the surface. So when the cold water rises to the surface, the cold water is usually nutrient rich. Why? Because all of you know that whenever any organism die, the sediments are deposited at the bottom, and if the water is coming from the bottom, it would be naturally rich in nutrients. So as the cold water rises to the surface, it brings nutrients to the surface. So this is upwelling. But in case of the El Nino year, the sea surface is warmer here and the trade winds are weakened. So when the trade winds are weakened, the upwelling also weakens along the west coast of South America. And ENSO impacts the weather pattern around the world, and sometimes we also call it as teleconnections. Why teleconnections? So the events which are happening in the Central Pacific Ocean, in the Eastern Pacific Ocean, those events are linked to the Indian monsoon. Indian monsoon is a phenomenon associated with the Indian Ocean and the Indian subcontinent. It is getting impacted by something which is happening in the Central Pacific Ocean. So this is some kind of teleconnection. It is also related to Indian monsoon, and what is the exact relation we don't know, but the data points to this condition that whenever there is El Nino year, the monsoon is deficient in India most of the times. I am choosing the word most of the times, not always. Sometimes during the El Nino years also, India has received good monsoon. But generally, the higher probability is that in the El Nino year, the monsoon is deficient in India. Moving ahead. In general, the warm El Nino events are characterized by more tropical storms and hurricanes in the Eastern Pacific and a decrease in the tropical storms in the Atlantic and Gulf of Mexico region and in the Caribbean Sea. So during the El Nino year, we are having warmer sea surface in the central and eastern part, so the frequency of the tropical storms and hurricanes increases in the eastern part of the Pacific Ocean. Let me show you this on the map. Okay, we can show it here. So this is the eastern part of the Pacific Ocean. In case of El Nino, there are warmer sea surface temperature here. The sea surface temperature rises here. So the water is warmer, and there would be more cyclone storms in this region. There would be more cyclones and storms in this region, and the cyclones in this part, in the Caribbean Sea, in the Gulf of Mexico, decrease. In the Atlantic, the incidence of the cyclones decrease. The incidence of the hurricanes decrease. So this is also one of the telecommunication. We have seen that the El Nino is negatively correlated with Indian monsoon, and La Nina is positively correlated with Indian monsoon. In case of the La Nina year, the Indian monsoon increases. We are having higher probability that the rainfall would be good in the Indian subcontinent region. So the La Nina suppresses the hurricane activity in the central and eastern Pacific basins, and it enhances the intensity of the hurricanes in the Atlantic basin. So during the La Nina year, the frequency of the hurricanes will increase in the Atlantic region, and the frequency of the hurricanes in the Pacific region will decrease. Why? Because the sea surface temperature is decreasing in the central and the eastern part. So the intensity of the frequency of the cyclones is more in the Atlantic region, and the frequency is less in the Pacific region. And it is positively correlated with, La Nina is positively correlated with the Indian monsoon, and El Nino is negatively correlated with Indian monsoon. There is one more thing. So during the El Nino event, we know that the temperatures are rising in the eastern part and the central part of the Pacific Ocean. So when the sea surface temperature is more, you know that the water expands with the rise of temperature. Okay, one of the factors that the sea level is rising is the rising temperature, and temperature is a very prominent factor, the major factor as compared to the melting of ice. So the expansion of water is a major reason for the rising of the sea level. So if the temperature rises in the central and eastern part, the sea level in this portion also rises, and the sea level rises appreciably. When the scientists are monitoring the sea surface temperature and the conditions in the central and eastern Pacific, so they basically monitor the sea level in this part. If the sea level is rising, that is also an indication of El Nino. Always remember this. Whenever the sea level is rising in this part, that is an indication of developing El Nino. And there are many other factors. We are also monitoring the sea surface temperature. We are collecting a lot of data regarding the sea surface temperature from these parts. And during the El Nino event, the sea surface temperature is decreasing, and when the sea surface temperature is decreasing, here the sea level is slightly lower as compared to this part. Okay, the sea level is slightly lower as compared to this part, that is the West Australian part. I hope that this topic is very clear. Now sir, finally I am telling you that this is the South American coast, and in case of El Nino, we are having warmer sea surface, the warmer water in the eastern part of the Central Pacific Ocean. So there would be dry conditions in case of El Nino in Australia and nearby and in Indonesia, and there are warmer conditions near the Peruvian coast. The rainfall will increase near the Peruvian coast, and the rainfall pattern will shift in the eastward direction. So a question may be framed like this, that with El Nino the rainfall pattern shifts eastward, so that statement would be correct. If I say that in the El Nino year the sea level rises in the central and eastern part of the Pacific basin, then this statement is also correct. So I hope that you have understood this phenomena of El Nino and La Nina, and I am having some data with me. This data is from 1950s to 2010s. This data is for every year since 1950. So for all these years, we are having the average temperature for every year, and we can clearly see that the average temperature is on the rise. So this is the surface temperature, and this temperature is given in degree Fahrenheit, and 1.8 degree Fahrenheit is equivalent to 1 degree Celsius. So we can very clearly see that the average temperature of the surface of the earth is on the rise. And we have also noticed one thing, that so you can see the red dots in this graph. Those red dots are indicating that these are the El Nino years. So El Nino years are usually those years where the average temperature is more than the normal. The average sea temperature is more than the normal. Most of the time, El Nino year is that year where the sea surface temperature is more as compared to the other nearby years. But this is not always true. Sometimes the sea surface temperature is not that much, but we have seen the changing weather patterns. So most of the time, the El Nino occurs in those years where the sea surface temperature is more than the normal. So this is all for now, and I hope that you have understood everything that we have discussed in this class. Thank you.